Imagine looking in the mirror and realizing that the color of your eyes isn't just a random trait. It's actually a biological record of human history. Long before modern medicine or sunglasses existed, the color of someone's eyes helped them survive in very different environments. The shade in your iris reflects thousands of years of migration, climate adaptation, and genetic chance. Around 70% of people on Earth have brown eyes, while the rest carry variations that emerge through rare genetic changes over time. Each color, from deep brown to pale gray, tells a story about how humans spread across the planet and adjusted to new conditions. I invite you to comment what type of eye color you have. Let's begin with brown eyes, the most common eye color in the world. That rich dark tone comes from high levels of melanin, the same pigment that gives color to our skin and hair. But melanin does much more than create color. It acts like a built-in protective filter. In bright environments, especially regions close to the equator where ultraviolet radiation is strong, melanin absorbs large amounts of incoming light before it reaches sensitive eye tissues. Scientists have shown that darker irises can absorb most of the light entering the eye, reducing glare and helping maintain clear vision in intense sunlight. For early humans living under constant sun exposure in Africa and other tropical regions, this wasn't simply a cosmetic trait, it was a survival advantage. People with darker eyes could see better and protect their vision over time. That's one reason brown eyes became the dominant eye color across the planet. If you're interested in this type of content, don't forget to subscribe to the channel and give us a like. Now consider blue eyes, one of the most fascinating examples of genetic change in humans. Genetic studies have traced blue eyes back to a single mutation that appeared thousands of years ago in one individual. Before that mutation occurred, every human likely had brown eyes. The mutation affected a gene involved in controlling melanin production in the iris. Instead of producing large amounts of pigment, the iris produced very little. Surprisingly, blue eyes don't actually contain blue pigment. Instead, their appearance comes from the way light scatters through the structures of the iris. Short wavelengths of light, those that appear blue, bounce back out toward the viewer, similar to how the sky appears blue due to atmospheric scattering. As a result, blue eyes can shift in appearance depending on lighting conditions, sometimes looking bright icy blue, sometimes pale gray. When this mutation appeared during early human migrations into northern regions, it spread quickly through populations. Researchers believe the spread may have been influenced by a combination of environmental conditions and social factors. In areas with long winters and lower sunlight levels, lighter eyes may have allowed slightly more light into the eye. Others believe rarity made them visually striking, increasing their attractiveness and encouraging the trait to spread through generations. Even rarer are gray eyes. Only a small percentage of people worldwide have them, making them one of the least common eye colors. Gray eyes contain extremely low levels of melanin, even less than blue eyes. Instead of scattering mainly blue light, gray eyes disperse a broader range of wavelengths, giving them their steel-like appearance. Depending on the lighting, they can look silver, slate-colored, or even slightly green. Because they lack pigment protection, people with gray eyes can be more sensitive to bright sunlight. Yet in dim or cloudy environments, this low melanin structure may provide a small advantage by allowing more light to reach the retina. In regions where overcast skies were common for much of the year, such sensitivity may have helped early populations navigate their surroundings more easily. Gray eyes also carry a certain cultural mystique. Because their tone tends to remain neutral and less vibrant, they've often been associated with calmness, wisdom, or emotional restraint in literature and folklore. Green eyes are even more unusual. Only about 2% of the global population has them. What makes green eyes particularly special is that they result from a delicate balance of genetic factors. Multiple genes contribute to how melanin and other pigments appear in the iris. Too much pigment and the eyes appear brown, too little and they appear blue. Green eyes exist somewhere between these extremes. In addition to moderate melanin levels, they contain a yellowish pigment that blends with scattered light to create the green tone. Because of this complex mixture, green eyes can appear to change depending on surrounding light, clothing colors, or even the environment. In shadow they may look deep mossy green, while in bright light they can appear golden or hazel. Historically, green eyes have captured human imagination more than almost any other eye color. In medieval Europe they were sometimes linked to mystical qualities or supernatural abilities. In mythology and storytelling, they often symbolized mystery, creativity, or intuition. From an evolutionary perspective, this balanced pigmentation may have offered flexibility in environments with mixed lighting conditions such as forests or mountainous landscapes. Another fascinating color is hazel. Hazel eyes are famous for their ability to appear different from moment to moment. Unlike most eye colors that stay relatively consistent, hazel eyes can shift between shades of green, brown, and gold depending on the lighting. This happens because hazel irises contain intermediate levels of melanin along with small amounts of yellow pigments. Light entering the eye interacts with these pigments in different ways, creating a dynamic appearance. In evolutionary terms, hazel eyes sit right in the middle of the pigmentation spectrum. They offer some protection from bright sunlight while still allowing a good amount of light sensitivity. This balance may have made them useful in environments with constantly changing lighting, places where people moved between open landscapes, shaded forests, and seasonal climates. Roughly 5% of the world's population has hazel eyes, and the exact pattern of colors inside the iris can vary dramatically from person to person. Two individuals with hazel eyes might have completely different distributions of green rings, brown spots, or golden tones. Then there are amber eyes, one of the most striking and often misunderstood colors. Amber eyes have a distinctive golden or copper tone that tends to remain consistent regardless of lighting conditions. Unlike hazel eyes, which shift appearance, amber eyes maintain their rich warm hue. This coloration results from a higher concentration of yellowish pigments combined with relatively low melanin levels. Interestingly, this color is also seen in many predatory animals such as wolves, eagles, and owls. Because of that association, amber eyes can appear intense or powerful to human observers. Some researchers suggest that humans may subconsciously interpret this color as a signal of alertness or confidence. From an evolutionary standpoint, amber eyes may not have emerged primarily due to environmental adaptation but rather through social preference. Their unusual appearance could have made them more memorable or attractive, encouraging the trait to persist across generations. People sometimes talk about black eyes as well, but in reality true black irises don't exist in humans. What appears black is actually an extremely dark shade of brown with very dense melanin concentration. When so much pigment is present, the iris absorbs nearly all incoming light, giving it a deep, almost black appearance. This type of pigmentation is especially effective at reducing glare and filtering ultraviolet radiation. In regions with intense sun exposure, such as equatorial areas, very dark eyes offer excellent protection against long-term damage. Because they absorb so much light, they also tend to appear visually stable in almost any lighting condition. Many populations in Africa, South Asia, and Southeast Asia have very dark brown eyes for this reason. The dense pigmentation also makes subtle changes in the pupil harder to see, which may contribute to cultural perceptions that very dark eyes appear mysterious or difficult to read emotionally. Another rare phenomenon related to eye color is heterochromia. This occurs when someone has two different eye colors or when sections of a single iris display different shades. It affects less than 1% of people worldwide. Heterochromia typically results from uneven distribution of melanin during early development. Sometimes it's caused by small genetic variations or a mosaic pattern in the way cells form the iris. In most cases it has no effect on vision and simply creates a unique visual pattern. Throughout history, individuals with two different eye colors have often been surrounded by myths and symbolism. Some cultures viewed it as a sign of special abilities or spiritual significance, perhaps because it breaks the symmetrical patterns we normally expect in human faces. When you step back and consider all these variations, eye color becomes far more than an aesthetic detail. Each shade represents a combination of genetics, environment, and chance shaped over thousands of years. Darker eyes protected early humans from harsh sunlight. Lighter eyes emerged as populations migrated into new climates with different lighting conditions. Rare colors spread through a mixture of survival advantages, cultural influences, and simple genetic diversity. So the next time you notice the color of your eyes or someone else's, remember that you're looking at the result of an extraordinary evolutionary journey. Inside that tiny ring of color lies the story of ancient migrations, environmental challenges, and countless generations adapting to the world around them. Your eye color isn't just a physical feature. It's a living record of human history written directly into your DNA. Thanks for watching. Subscribe to the channel for more fascinating science videos and check out the next video to keep exploring.